Alright, let's go ahead and try to graph another quadratic function. It's right here, y is equal to negative x plus 2. So we want to go ahead and start by identifying our a, b, and c. Right. And first of all, we would want to write it in standard form, right? In the form y is equal to ax squared plus bx plus c. If it's not, but this one here is, right? So let's go ahead and identify our a, b, and c. Our a is the coefficient in front of the x squared. That's going to be negative 1. Our b is the coefficient in front of x. That is 0. And our c is the constant at the end, which is 1. Alright, so now we're going to identify our vertex, the x-coordinate of our vertex, and also the location of our vertical axis of symmetry, right, which is following this formula here. X is equal to negative b over 2a. So negative b is going to be negative 0 over 2 times negative 1. So our x-coordinate of the vertex is 0 right here, right? Our axis of symmetry is going to be right there at x is equal to 0. Alright, so using that vertex, we're going to use that as our starting point in our table. We'll use the 0 as the x of our vertex. And since x is 0 is the location of the x-coordinate of the vertex, we're going to use negative 1, negative 2, positive 1, and positive 2. If 3 was our vertex, we would use 2 and 1, and we would also use 4 and 5 for our symmetrical table. Okay. So here, let's go ahead and start by using negative 1. Well, y is equal to negative x squared plus 1. So we first need to square negative 2, right? X squared. So that's negative 2 times negative 2 is positive 4. But then we need to have a minus there, right? So it's going to be negative 4 plus 1. Negative 4 plus 1 is negative 3. Now we're going to do negative 1. So it's negative 1 times negative 1, that's positive 1. But then we have a minus, so it's negative 1. Plus 1 is 0. On 0, it's going to be 0 plus 1. So we have a 1. On 1, we have 1 times 1 is 1. Minus is going to become negative 1. Plus 1 is 0. And you'll see here that once you get the points to the left of the vertex, they are also the points to the right of the vertex. Right? You're going to see that this value here is negative 3. So we have 2 times 2 is 4, but it's negative, so it's going to be negative 4 plus 1 is negative 3. You see that? So 1 point to the left of the vertex is 0. That means 1 point to 1 unit to the right of the vertex is 0 as well. 2 points to the left of the vertex is negative 3 on the y, which means 2 points to the right of the vertex on the y is negative 3. Right? So let's go ahead and graph it. It's negative 2, negative 3. That's this point here. Negative 1 and 0. 0 and 1, and we have 1 and 0, and then 2 and negative 3, like so. Right. So let's go ahead and draw our quadratic function, like that. And then we're going to state our domain and our range. And so what you're going to notice here is that all of the quadratic functions have the same domain, right? Because it's either going to be opening upward that way, or downward that way. And so the possible x values are going to be all real numbers from negative infinity to positive infinity, right? It's where the range is that changes amongst the different quadratic functions. So state the domain, it's all real numbers. Alright, state the range. Well, what's the range? Well, the y values, there are possible y values on this function at y is equal to 1 and below, right? So what we're going to state here for our range is y such that y is less than or equal to positive 1. Right? Because for positive 1, there's a x value on the graph. For 0, there's an x value on the graph at -1, at +1. For -3, there's a x value on the graph. It's -2, +2, right? But for +2, there is no x value on the graph. For +3, there is no x value on the graph. So that's why we say all y such that y is less than or equal to 1 is the range, right? All the y values from 1 on down.